Welcome back, everyone. This particular video is about pattern matching basics. Now, pattern matching is an ocean in itself. You need to spend considerable amount of time learning and practicing F sharp to know the width and height and breadth, everything about of pattern matching alone. The goal of this video for me is to establish what pattern matching is as opposed to how to do pattern matching and what are the possible 30 ways you can utilize pattern matching and syntaxes and complex cases, etc. That's not the goal of this video. In this particular video, my goal is purely to establish why do you need pattern matching. Was the thought shift, was the uh, approach shift which is needed to understand and appreciate pattern matching in F sharp or in functional programming languages. So before we discuss pattern matching, we have to first of all understand a big difference between statement and expression. And uh, this is one of the areas where I personally struggled for a long time, especially when I started programming in F sharp. I could not stop thinking in statements because that's what I did for almost 18 years of my life as a programmer. I thought of breaking down problems into statements. That's what I was taught, that's what I practiced, and that's what I excelled at doing, thinking of breaking down a problems into statements, and then those statements do whatever those statements do. There's nothing wrong with statements per se in isolation, especially in the imperative world. There's nothing wrong with statements, but the reason statements don't fit in well in functional languages is because there are not too many statements that are available, or the possibility of writing statements. The whole language and all sorts of functions are geared towards expressions. The more you think in terms of expressions, the more you will find yourself at home. The more you think in terms of statements, the more you will find yourself, there will be more friction that you will feel, so much so that you may want to leave functional programming. Okay, so first thing I wish to explain is the key difference between statements and expressions. Now, a statement is anything which is about an instruction of sort. Do this and do that. And so I've created I've opened two sample play areas where one where we'll write F sharp code and the other where we'll write the C sharp code. And, you know, int x equals to 10, int y equals to 20, and perhaps do this. IntelliSense, welcome to Visual Studio Visual Studio. These are statements. Now you may have if x equals to 10 x plus plus, and so on and so forth. The whole thought process of imperative programming is about micro instructions where you try and control nearly every aspect of a program, including comparison, branching. Branching means, ifs and switches and jump from here to jump there, to assignments, to function calls and throws and catches and whatnot. This thought process doesn't fit well in functional programming. Functional programming is about expressions because functional programming largely comes out of category theory. Theory comes out of maths, and in maths, you have expressions, you have functions that compose, and everything there is expressions. Now, very simply put, an expression is something which can be squeezed down to a value. And that value may be anything. That value may be an integer, that value may be a string, that value may be a function, that value may be a list of integers, that value may be an int option and whatnot. But if you solve If you keep on solving the expression and squeezing down, squeezing down, squeezing down, you'll end up with a value. That's what an expression is. So, functional programming is all about expressions. And here is one example of F sharp which I lifted from MSDN to just to show what I'm trying to say here. So this is a function which does whatever it does, and then this is a list of numbers, and there's this function invocation here, this function. And the example that I'm trying to give here and I'm trying to quote here is that here everything this is an expression. If you keep on solving this, you will end up with a value. Pay attention, a value could be anything. It need not be an integer, a small value. It can be a ginormous universe wide long value. It could be 0, it could be -1, it could be instance of a record called student, a partially applied function, and no surprise, everything is value in F sharp. So when you solve an expression, you end up with a value. That's what an expression is. On the other side, statements are terminal points. Do this and then do this and then do this. They may be connected and they should be connected, because and otherwise what's the point of writing statements in a program? But statements don't result into value. Expressions result into values. And I've tried to explain in different ways the differences between statements and expressions. And another thing I've tried to explain here is that when non-functional programmers try to learn functional languages, there are two main impediments. One is they get lost in jargon, which is all the fancy words, which is, functional languages, thanks to category theory, are full of crazy words which are very, very alien to the, the people who don't have that background. For example, map, bind, apply, functor, monoid, monad, and whatnot. These terms are difficult to understand, especially for those who come from imperative languages, and it's difficult for people like us to stop thinking in a statement-driven fashion. It's difficult because that's what we learned and practiced and mastered over many years. Now here's a simple C sharp example which I have given on the blog to exemplify what I'm trying to say is the thought shift from thinking in terms of instructions to thinking in terms of expressions. And here's a very simple C sharp example, that here's a function which gets any number and returns true if the number is even, and returns false if the number is odd. And this is the most obvious way of writing this function. And then I use the tertiary operator to move towards an expression. And this is the best I can do in C sharp to convert this function entirely into an expression. Now you can clearly see here that this is an expression. Given a number, I'll either end up with true or I'll end up with false. If you solve this, you will end up with some value. You'll end up with something, and that something is the return value of this function. If you wonder what's the difference between this and this, is the approach difference. That approach is not really problematic in C sharp, but it becomes really crazily problematic in F sharp. In C sharp, it doesn't really matter. It's more of a taste and preference. But the key difference is, if you look here, here's a condition, here is a command, here is a statement, here is me telling the compiler explicitly that if this occurs, return true. This is a terminal condition. Otherwise, this, another terminal condition. This on the other side is saying this is whatever this comes out to be, whatever it is, doesn't matter. Do that. So that's the fundamental difference between statements and expressions. And expressions are important because, again, I've tried to explain here is expressions allow you to compose bigger expressions, just like functions allow you to compose bigger functions. A record type in F sharp would allow you to compose a bigger record type. A discriminated union can also be used to compose more complex data types, and so on and so forth. Expressions give you the capability to compose more and more expressions. A bigger expression is actually, going back to this example, this expression is combination or composition of multiple expressions. And that's the beauty of expressions. If you start thinking in terms of expressions, you are thinking in a sequential flow. You're not thinking in terms of commands, statements, terminal points, do this, do that. You're always thinking in terms of an assembly line in an automobile factory, where there's one end of the assembly line, there's other end of the assembly line, and everything is things happening on that assembly line, as opposed to random jumps and branchings and comparisons and whatnot. I totally understand that for newcomers, for people who are beginning in the functional world, it's difficult to imagine programming in such a way is even possible, but it works. So we will see how it happens. So now let's see what pattern matching is. Pattern matching, for the lack of better words, is either switch cases on steroids or if else ladder on steroids. That's what pattern matching is. And so let's just see. So here's a very simple pseudocode implementation. You can do this in any C, C++, Java kind of language. There is some input, and what we are doing is, if the input is 1, we are printing 1. If the input is 2, we are printing out 2. If the input is none of these, we are saying unknown. And this is a typical template in nearly all imperative languages. You may also use a switch like ladder, but the effect is more or less the same. The same example is written in pattern matching. So let me just copy it. And I'll just say 1. Now let's understand what is pattern matching. Pattern matching is match something, could be anything, with, like discriminated unions, you have cases. Case 1, case 2, case 3, you can have 1 to infinite cases depending upon what you're doing, what the need is. And here what we are doing is we are matching number with 1. And if we remember the lambda, this is how you create a lambda. Let x equals to fun y plus 1. So if you pay attention, this resembles this. You have something on the left side of the arrow, you have something on the right side of the arrow. Similarly, what you're saying here is match this number with 1, and then if that is the case, here's an expression. Similarly, even with a lambda, what follows on the right side of the arrow is an expression. Even with a function, what follows the function body is an expression. You may wonder, oh, is this all of this really an expression? The short answer is yes. The long answer is not the right time to discuss it, but all of this boils down to an expression. But that's a different discussion altogether. Match number with possibilities. Possibility number one, if that happens, the expression to return, which is when this collapses, you end up with a result. The result in such a case should become 1. If not true, that is match another case. If this number is 2, this expression should collapse, or this expression should result into 2. And this underscore here is the wildcard, no match, or catch all case. That if these two cases were not successful, here is your else in the imperative world. You end up with else, and I'm saying unknown here. Now, the difference between this and a switch ladder or an if else ladder is what happens inside switches, switch cases, or if ladders is you put in statements. Switch ladder or if else if ladder does not return a value. Those ladders or those expressions, those lines of code cannot be compressed into one value. On the other side, this gets compressed into one value, because for each case, your job as a programmer is to specify the expression, and that expression could be as simple as this example, or it could be an extreme complex case of invoking a function chain, or composed functions, or invoking a function pipeline and whatnot, as we will see over time. So if I run this example, I should see 1 if I'm correct. What happens? Yeah, 1. If I change this to 2, and again, because this is collapsing, or this is being squeezed down to a value, that value gets in the result, and result is what I am printing. If I change this to 2, I get 2, and if I change this to anything, minus 100, and I get unknown. So pattern matching is match whatever, and that whatever could be anything. There are all sorts of fancy things that you can do pattern matching against. We will discover how, with the possible cases. A lot depends on the type of data you are dealing with. Here you are dealing with this number being an integer, right? So there are only so much cases which are possible, and this is what I've tried to explain. Here we apply pattern matching on number. The expression starts with match to be matched with multiple cases that you wish to handle. On the left side is the constant value in this example here, and on the right side is the result expression. Now, since this is an expression, now I'll just write this whole thing in a different manner. I'll write result and I assume you are fine with that. The result becomes the parameter after result comes here. Imagine this question mark getting replaced by result. Why? Because result is a value which becomes the second parameter. After printf %s comes the second parameter to printf. So result becomes the second parameter here. Now I have been saying that this gets boiled down to, squeezed down to, collapse to a value. So let me prove it. Here you go. Match number with whatever the answer is comes here, and let's see what happens. Unknown, because the value of number currently is 100. Let me just change it to 1 and 1. This is impossible with statements. So if I write it in just one line, for reading's sake. Ignore the warnings and so on and so forth. This is one thing up to here. This will become a value, and you can do whatever you want to do with a value, and that's the strength of expressions. So pattern matching in a different way is, you have something in a pipeline, in a function pipeline, etc., and you want to produce something else out of it. So we had a number in a pipeline and we wanted to produce a string out of it, and that string is what we printed. So let's take this pattern matching and put this in a function. Let num to string num equals to this. No. So I'll get rid of this. What's wrong with this? Oh. Now, instead of doing pattern matching, here I'll say number goes to a function, and a function does this, and that goes to console. How is this different from this? There is no difference. It's a difference of perspective. Here we could see that between number and printfn we can inject num to string in the pipeline, because number was sent to a function produced a value, that value goes to printfn. Similarly, this is nothing but a value. As this resulted into a value, this results into a value. As the output of this much could be passed to this, the output of this much can be passed to this. This is where thinking in expressions changes the game. It completely changes the way you attack the problems, you think of the solutions, you think of building pipelines when solving problems, as opposed to thinking of statements and jumps and control flows. I'll just write down this whole example in a completely different manner to introduce one more topic, because it's a very frequently used technique in F sharp which syntactically look tricky. So instead of num to string, I can use a lambda. So I'll just copy this much to make my life easier. I'll get rid of this. So instead of using a function, I'm going to use a lambda. Fun x equals to match x with so number goes to a function, and the output of this function goes to printfn. Now, up to this point, you should not have any confusion, because this is going to get slightly complicated from here. So I'll once again repeat, number was passed to this, and the output of this was passed to this. Instead of this function, I'm using a lambda, which is nothing but this function. It's a copy paste of this function essentially. It's a syntactic thing right now. So this lambda says give me one number and I'll do pattern matching over this number, and whatever is the output of this expression with the output of this lambda. Now this is a very common occurrence in F sharp. That is, you are creating lambdas for a single parameter, because pattern matching is such a common thing in F sharp. Pattern matching comes right in between the pipelines where you take some input and produce some output and the pipeline continues. So there's an alternate syntax that you can replace this much, which is function. And remember, this technique is only and only applicable for three conditions. These three conditions must be true. And believe you me, these three conditions are true more often than not. You are doing a lambda, you're creating a lambda. That lambda has only one parameter, it's not a multi-parameter lambda. And with that parameter, you're doing pattern matching. If all these three conditions are true, you can replace this much with a keyword called function. That's it. So function is syntactic sugar, and if you read the description, it says used as a shorter alternative to the fun keyword and a match expression and a lambda expression that has a pattern matching on a single argument. So function is a syntactic sugar for this. You can write lesser amount of code. Once you are used to of reading this, you know, all right, this is a function which has one parameter and you're supposed to do pattern matching on that one parameter. So it's not a function, it's a lambda with one parameter where the sole purpose of that lambda is to do pattern matching. Okay. So number goes into the lambda produces output which goes to the function. So once again, think in terms of expressions, and pattern matching is one of the key building blocks in F sharp where you will have to think in terms of expressions. The more you practice pattern matching and stitching pattern matching as part of the solution to a problem, it'll help you think in expressions. Okay. This is the same example that I talked about, and this is another example that I'm talking about. It's not just the expressions that you need to pay attention to. Is ultimately, as a functional programmer, your job is, or not your job, you will excel when you think in terms of transformations. What is happening here? Number goes to a function which produces a string which goes here. So what is this function doing here? It's a transformer. What is this expression doing here? This expression was triggered with a number. It ended with a string. The ultimate goal of functional programming, at least to my mind, and I don't consider myself an expert, but the ultimate goal when working in a functional language is to think strictly in terms of transformations. If you are unable to think in terms of transformations, there are only two possibilities. Either there's a lack of understanding, or there's a lack of tools. You need to gather more tools, more techniques. You have to solve, you have to bring more container types, you have to find more functions. All of that will come in future in your life. Okay. So here's an example. Let me just copy this example. So here's a function called string to int, which converts a string into integer, and here is an integer to string. There's nothing fancy about these functions, but this is a transformation pipeline. You have a string which goes to this function, and from there it goes to this function, and from there it goes to this function. So it's a transformation pipeline, and then I'm using this pipeline, a variant of this pipeline, as this string goes to this function, same here and here, and instead of going to int to string, it goes to our dear lambda that we created here. It goes here. You can actually get rid of these brackets. So string goes to a transformer function which converts it into an integer. Then it goes to a transformer function which takes this number and produces a string, and that goes out for printing. So the key message that I have for you as a conclusion of this particular video is think more and more in terms of expressions. It's a slow process, and this is what I have also recommended in this particular section, that while learning and practicing F sharp, every time you are about to write a statement, a command, or an instruction, take a break. Remind yourself that you need to figure a way out to use expressions, not micro instructions. And then I explained, I gave this example. So when you're learning or practicing F sharp, think more in terms of expressions. That's your immediate goal. You cannot think in terms of statements anymore. And think the bigger goal, the bigger problem, the ultimate philosophical goal is to think in terms of transformations. And slowly, as you learn more tools, more techniques, more abstractions, more functional patterns, for example, monads, monoids, functors, applicative functors, those are nothing but transformations, believe you me. They are all fancy names for transformations. You have something in shape X, you want something out of it in shape Y. Put a transformer in between. So all sorts of fancy things we will talk about in future is all about transformations. So on that note, I'll conclude this one. Thank you. See you later.